Okay, so we're going to be in section 11.4 today, and we're talking about simple closed surfaces. This is where we're going to start. We're going to get into looking at several three-dimensional shapes, and really this section is a lot of terminology. It's a lot of just basic information about these 3D shapes. So in your math lab, you're going to see questions that are going to ask you about the number of vertices or the number of sides or the information about bases and things of that sort. So there's not a ton of mathematical problems to work out. And on your test that you're going to take, you're not going to see a ton of questions that are mathematical. Let's solve an algebra problem, but it's going to be focused more on, do you know the terminology? Do you know how to identify these different types of shapes? And so the first kind that we're going to talk about is what we call a simple closed surface. So if you remember in previous sections here in chapter 11, we've talked about simple closed surface and shapes. So for example, our simple closed curve, we would say that maybe that is a simple closed curve. That's a two-dimensional shape. Well, now we're going to get into talking about three-dimensional shapes. In our three-dimensional shapes, we refer to them as surfaces. And so a simple closed surface is going to be all the points that are on the that are going to be made up by this three-dimensional shape. And there's not any holes. It's not hollow. I'm sorry, it is hollow, but there's no holes through it. And so we call it a solid shape. And so you can see some examples here. These first four examples are examples of simple closed surfaces. So you can see it's a three-dimensional shape. The dotted lines that you see on each of those are the ones in the back. And there's not any holes in them. They're made up of simple closed curves. All of their shapes that they're made up of are simple closed curves. And so when you put those together and you form this 3D shape, it doesn't have holes. It's not made up of points on the inside. It's just the outer shell, essentially. And so you could see a lot of these as you go to, let's say, the grocery store. As you get out and you buy things, the containers oftentimes are simple closed surfaces, and some are prisms and some are cylinders, and we're going to talk about all that in a little while. But they're simple closed surfaces. So it's that idea of the outer shell, the container maybe that you would buy something in. For example, if you were to go buy a can of vegetables at the grocery store, well, that can, the can itself, would be a simple closed surface. And so we'll talk more about that coming up. If you'll notice that these two shapes at the bottom, these two surfaces at the bottom, they are not simple closed surfaces. Number one, this cube shape has a hole through the middle of it. And so because it does have that hole, it is not closed. It's open through that. And then the other one is not a simple closed surface because it does cross each other. So remember, we've said that it is simple if it doesn't cross each other. It is closed if there's no way to get into it. And so the cube shape has a hole through the middle of it. The two pyramid shapes on top of each other would cross if you're trying to draw that. So some different types of shapes or surfaces that we're going to talk about. One is a sphere. And you know what a sphere looks like. It's a ball shape. The earth we talk about being a sphere shape. But really any kind of ball would be in a sphere shape. And it's defined as being the set of all points at a given distance from a given point. So if you remember when we talked about a circle, so we said that a circle is all the points that are equidistant from a center point. And two-dimensionally, that's true. That's all the points in that one plane. Well, now we're talking three-dimensional, where we have multiple planes being used. And so it's all the points that are the same distance from a center point. So think about this. If you were to take a circle on your piece of paper that at the table that you're sitting at or the desk you're sitting at, if you were to draw that circle is sitting on that paper, right? But if you were to go take a ball, some kind of ball, and sit it on your paper, well, all those points are not in the same plane. Remember, your plane is a flat surface, so your paper would represent that flat surface, but that ball is going to sit on top of that. And so it has multiple planes that are being used. And so when we talk about a sphere, it's the center, inside the center of that sphere, that ball shape, and it's every single point that exists that is the same distance from it. And so it does form that ball shape. Now, the next word is what we call a solid. And this is the set of all points on a simple closed surface together with all the interior points. So when we talk about the surface is the outer container, right? The can of vegetables or whatever that you might buy at Walmart. Those are the outside is the surface. We call it a solid figure if we're including all the points on the inside too, where it is a solid, right? If you think about hollow versus solid, we said that the surface itself is hollow, but the solid contains all the points on the inside. And if we were in school in person, I would have a lot of different solids that I could show you, and you can see how they're solid all the way through. Whatever the material is on the outside is the same on the inside. So I would encourage you to look some of those up just to kind of get a picture in your mind. You can actually look in your book starting on page 715, I think. Yeah, around page 715, 714, 715. You can look at some various shapes, and our book has several of those that you can see. Now, what we're going to spend a lot of our time talking about here is what we call polyhedron. Polyhedra is the plural of that, but polyhedron are simple closed surfaces made up of polynomial regions that we call faces. So again, I'm going to show you some examples of this in a second, but as we talk about these faces or these sides, if you will, for a polyhedron, they have to be polynomials. Can't be circles, can't be anything that's got a smooth curve. It's got to be a polygon. And the vertices of the polygonal region are, the polygons of the, gotta get my words right. The vertices of the polygonal regions, those faces, make up the vertices of the polyhedron. And the sides where each polygon meet are what we call the edges. And so again, I'm going to show you an example that's got all of that in just a second. So here's a couple of examples of polyhedra versus non-polyhedra. So the two that are polyhedron, you have really three parts we need to think about. Number one are the faces. So the faces are the sides. So for example, that rectangle would be a side of this polyhedron. It is a face. We refer to it as a face. You have another face on this back part, this back triangle. Back rectangle. It is also a polynomial. Excuse me. And then also you'll notice that the triangle piece on the top and the one on the bottom, those two are also polygons. And then, of course, you have the one on the front side as well. So those are your faces. Your edges are the sides. So you can see all of these sides would be considered edges. And then where all these meet at these points, just put a few in here, those are what we call the vertices. You have one in the back, and so on. And so you're probably familiar with how to draw a three-dimensional cube. If you are familiar with that, you know you draw a square, and then you draw another square kind of offset from it. And then you can connect those vertices. Now, when you do that, if we use dotted lines, it would make the back part of that a little bit easier to see. And it's almost kind of, it'll play with your eyes a little bit. It's almost an optical illusion because you don't know maybe which side's front, which side's back. But you can see that you start out with your faces, you draw those, and then you connect the vertices, which forms our edges. And so that's what's happening there. The next one is also a polyhedra. It has triangles as the sides and a rectangle or some kind of quadrilateral there as the base. And then it has a vertex here at the top. We'll name that one in just a minute. And of course you have vertices here at the bottom as well. You can see all of those. Now, the ones that are not polyhedra, the reason they're not polyhedra is because they have they don't have polygonal sides or faces. The sphere, again, is a round, circular shape. It's not a polyhedra. Same thing with the next one, the cylinder. It is also not a polyhedra. And then the first two we talked about, this cube shape, and then also this one, they are not polyhedra because they're not simple closed surfaces. Okay, so just be aware of that. Now, the next type that we're going to talk about is what we call a prism. So a prism is a polyhedron that has two sides or two faces that are congruent, so they're the same size and shape, and they're also parallel to each other. So you can see the ones that are labeled as being the bases. Those are parallel to each other. They're the same size and shape. And then the other faces are what we call the lateral faces. So the ones on the side. So this one, and then the one on the front side, which I'm not going to shade. Each of those are called the lateral faces. We talked about a few minutes ago the edges being the sides. You can see that here. And then we've also talked about the vertices being the points where those planes all meet, or those surface sides all meet. Now, a prism is often used in packaging. If you go buy many items, you oftentimes will see a prism. And that prism is, again, going to have the bases that are polygons. And then, of course, your sides are also going to be polygons. So it's going to end up being a polyhedron as well. So, again, you could look at a lot of different examples, and you can probably find prisms all around. A lot of times we think of cans in the grocery store, but if that can is circular, it's not a prism. So we'll name it in a few minutes. But you could still buy a lot of different products that come in prism shape containers. And so we have what we call a right prism, where the top base is directly above the bottom base. Now, notice our definition here says the lateral faces are perpendicular to the bases. Well, that's true, but if this base is sitting directly above this base, where this point and this point are above each other, and these back points are above each other, and same thing here, well, then that means that this line in the back, it has to be perpendicular to those bases. And this one is going to be perpendicular to this base and to this base, and so on. And so a right prism has lateral faces that are perpendicular to the bases. Basically, it means that the base on top is directly above the base on bottom. And so you can see each of these first three examples all are considered right prisms. Now, what you also notice is that the lateral faces are all rectangles. Because if it's perpendicular and all these lateral faces are perpendicular, then they're going to be rectangles every single time. But if you'll notice on this last example is what we call an oblique prism. So this one is a hexagonal oblique prism. What it means is that your two lateral faces are not perpendicular. Essentially, they're shifted over. So, if you put your hand on your table and that represents the bottom base, you could put your other hand directly above it and illustrate a right prism. But if you were to shift it over a little bit and then connect your two hands, again, both examples of polygons here, if you were to connect those, then you would have an oblique prism. And you can see how this base is shifted over from this bottom base.